Hello everyone, welcome to a new and fresh video. In this particular video, we are going to see about the Poisson distribution. So Poisson distribution is one of the most widely used probability distributions in a data science. So we typically use Poisson distribution when we want to measure the number of events per unit time. The number of events per unit of time. So to understand better, we will use we will see a use case. So what is that use case? Let's say uh, we have a capacity planning at a call center, right? Capacity planning at a call center. This is the use case. So it means at any call center, okay, at any call center we need a call center representatives to receive the customer calls. We need a representative which will who will receive the customer calls, okay. Or it could be, let's say you have an emergency center from people who are in distress and they need to take some actions or services to dispatch, right? So capacity planning means here means like how many people we need at the call center, right? Looking at distributions of calls that we have been receiving in the past. So to understand it in a clear way, let's say I have uh, uh, one example. See, number of calls you get at a call center. Number of calls you get at call center. So actually what is happening here? Getting a call. So call is nothing but an event. An event. Unit time is like 1 hour. Okay, is like 1 hour. So we are trying to get or study the number of calls, the number of calls per unit time. Let's say, so let's say take one more example. When you are studying in a college or university, let's take, there is an Amul cafe in your university, and you have to see like how many people are coming to that Amul cafe, right? Every 10 minutes, in every 10 minutes. So again, this is also a number of events that are happening for a unit of time. Let's take one more example. Let's say when you have a cell tower, when you have a cell tower, so like you have to think how many calls, how many calls arrive at the cell tower per unit time. So you have to understand how many events or phone calls you will have to receive at the cell tower, because it will help you determine how many cells tower you have to place in a specific region. Okay, so these are the things, right? So I will show you, like we discussed about the use cases, what is capacity planning, and something like we discussed about the example. See, let's you have a number of calls. This is one example that you are getting at a call center, and let's say in a Amul cafe, like in every 10 minutes how many customers are coming. Or you have one more example that is called let's say you have a cell tower and how many calls arrive at the cell tower per unit time. Okay, so further so like when you are applying Poisson distributions, there are a bunch of some necessary conditions that to be satisfied when you are using Poisson distribution. So the condition is like first condition is like event should happen at a constant rate. Event should happen at constant rate, which will denote with the lambda. So in the real world, if it doesn't happen at exactly a constant rate, and if it is approximately at a constant rate, it's good enough. Second one is nothing but events are independent. Events are independent. Calls, like take a calls example, calls that you are getting at a call center. Suppose me, as I'm making a call to the call center, is independent of you making calls to the call centers. These are the events are independent. If we talk about the third point, no simultaneous events. No simultaneous events. So these are the necessary conditions that need to be satisfied when we are applying the Poisson distributions. So there are some mathematics associated with the Poisson distribution. So what is that? So Poisson distribution is nothing but a discrete random variable. Discrete random variable. So we'll have a PMF, as we know, that is called as probability mass function. So actually why it is discrete? So because you can't because see, you can get the number of calls, such as like what number of calls can be 4, 5, 6, right? It cannot be like 4.5, 5.5, 6.5 something, right? This can't be. So the number of calls will be like this time. Okay, so we can write the PMF of probability of Poisson distribution is e to the power minus lambda upon k factorial, and its then its CDF will be what? This is the CDF and the PM of the Poisson distribution. So you can derive these two things mathematically. So by using the binomial distributions and using limits in the calculus, you can derive, or or say the second way is like by fitting a formula to the observations, right? So like what this Poisson says is like, so see what is saying that, like what is the probability that you will see k events. See, it's telling what is the probability that you will see the k events. So k is the nothing but the number of events that is happening. Number of events that is happening. Okay, lambda. Lambda is nothing but the rate at which these events are happening. The rate at which these events are happening. Okay, and x is nothing but the count, just count. Okay, so particularly we let me wrap up all these things. So first of all, what is Poisson distribution? This is one of the most widely used probability distribution in data science, and for the formal definition you can write like a rare event, how often rare events happen randomly over time or space, right? So we use typically Poisson distribution when we want to measure the number of events per unit time, right? Per unit time. And I discuss about the use case which is called the capacity planning, where I discuss like means how many people we need at the call center, looking at distributions of calls that we have been receiving in the past. And here are some of the examples, like number of calls which you get at the call center, what's happening here. Like you are getting a call yours is an event at a per unit time, which is called 1 hour, right? When we discuss about the cafe, which was Amul cafe, like in every 10 minutes how many people are coming there, right? When we talk about the cell tower, say like from this you can analyze like how many cell towers you need to place in a specific region. There are some conditions which need to be satisfied before applying a Poisson distribution. Events should happen at a constant rate. Events are independent. In which this events are independent is means, like suppose if I am making a call, right? Me making a call to the call center is independent, right, of you making a calls to the call center. There should not be any simultaneous events. As we can see, the mathematics which is associated with the Poisson distribution is like it is a discrete random variable. Why it is discrete? Because see, you can't get the number of calls like 4.5, 5.5. You can get it at 4, 5 and like 6. So here there is an PMF of here, and this is the CDF of the Poisson distribution. You can derive it using the two methods. The first method is like binomial distributions, applying and using some limits in calculus, and the second one is by fitting a formula to observations, right? And these all formula say this is k is nothing but the number of events that is happening, rate lambda is nothing but the rate at which these events are happening, and x is nothing but the con. I hope this makes you clear about the Poisson distribution. In some of the further videos we will see the derivation and implementation in the Python. Thanks for watching this video.